Here is such a nice looking problem that I found recently. If you want to solve this problem, please pause the video because I'm going to solve this problem right now. So what is the length of DE? So we have a right triangle ABC here. So the leg, one of the legs is 16, another leg is 12. We have the height here, which is the height to the hypotenuse. You have these two little segments equal, AE and EH are equal. What is the value of DE? So the first thing that comes to mind is writing the Pythagoras theorem, right? So this is a right triangle, so we can say AB squared plus BC squared equals AC squared. So let me just write it down here. AB squared plus BC squared equals AC, or hypotenuse, squared. So we have AB and BC, the legs here. So AB squared, 16 squared is 256 plus 12 squared is 144 equals AC squared. So these two become 400, right? And AC is square root of 400, or simply 20. So let's put a box around it. So we know the hypotenuse is 20. But in a right angle triangle, we have this beautiful formula for the height that is drawn to the hypotenuse and these two segments that are created. So whenever we have the height drawn from the vertex, from the right angle vertex to the hypotenuse, it is a geometric mean of these two little segments. In other words, it splits these hypotenuse into two little segments, and we have a relationship now for that. So we can say AB squared, so one of the legs, AB squared equals AH, which is the segment close or adjacent to the leg itself, times the whole hypotenuse. So let me just write it down here. It's, I think, called the altitude or height theorem in a right angle triangle. So we can say AB squared equals AH, or the segment which is adjacent to that leg, times AC, or hypotenuse. So let's just substitute. Now we can find AH and then just work it out all the way through DE. So AB is squared. So AB was 16. So 256 equals AH. So this is the variable. We then know how much is that, times AC, which is the hypotenuse, and it is 20. So in other words, AH equals 256 divided by 20, which is 28, so 12.8. So that's the length of AH, right? So AH is calculated using this formula. So let's also put a box around it. We know that AE and EH are the same, so they are equal. So we can say, for example, AE equals 12.8, which is AH divided by 2, which is 6.4. Let's also put a box around it. So now, after having found AE, and we have the legs here, so AB, BC, so we can now just write down the Thales theorem, just very easily calculate DE. So according to Thales theorem, we can say DE over BC, so DE over BC equals AE over the whole hypotenuse, because AE is the hypotenuse, this little hypotenuse of this little tiny square here. So AE over AC. So let's just substitute now. So DE over BC. So BC is 12 equals AE. So AE was 6.4 over AC. AC was the big hypotenuse, so that was 20. In other words, dE equals 6.4 times 12 over 20. We can just simplify that. So dE equals 3.84, so according to Thales' theorem. And that's the final answer. That was kind of an interesting question, not very difficult, kind of intermediate level. That's going to wrap it up for today, guys. I hope you enjoyed this video. And make sure to drop your thoughts and answers. So I'm sure this is not the only way. So there is a ton of other ways with which you can solve and approach this problem. So tell me your method and the approach with which you solve this problem. And make sure to like the video and subscribe to the channel. And see you on our next video on prime logic.